Hi, everyone. Thanks for staying till the very end of the talks today. My name's Lauren, she, her, and it's wonderful to be here with you all today. I hope you can see me. I'm a little short for this podium. Firstly, thanks to Thorsten and Grey Area and everyone working behind the scenes. I know it's been 2 years in the making and it's taken a huge amount of work to bring us all together physically and virtually. I'm an improviser, a sound artist, and a scholar working with live electronic musical performance for over the last 15 years. Today I'm going to talk about the evolution of what I do through the ideas of embodiment and sensuousness in relation to electronic and digital sound, and through inactive approaches to music cognition, which is to say that musicking, as we all know, is not something that just happens in our heads, but that we make sense that musical meaning emerges from the ongoing dynamic and physical interactions between, say, a musician, a listener, and their environment. And we've heard a lot of mentions of these ideas in some of the presentations today already. So the spaces that we make music in, the people or other beings that we make music with, and the materials that we use to enable us to do this. This way of understanding musical activity has provided a framework for a diverse range of projects that I've been able to take part in. They're part of my research, my teaching, and my artistic practice. So I'm performing tonight, but for those of you who may not be familiar with my work with improvisation and live electronics, I wanted to start by playing a recent clip of my music. I build hybrid analog digital improvisation systems, instruments for live electronic. I'm intentionally not good with definitions or categorization of these things that I make. They comprise of drum machines, analog synths, voice processors, various MIDI controllers, and software that I build using Max MSP. They're intentionally unpredictable, often difficult to play in that I often don't know what they're going to throw out at me, which I enjoy as an improviser. And the design is heavily informed by ecological or living systems where simple interactions can lead to complex behaviors. And I think John's performance kind of was exemplary of that earlier. So both audio signals and control data are entangled in messy and mutually affecting networks. I think of myself as a performer simply as part of the system or set of relationships along with the audience, the performance space, and all these materials. It's something I have to respond to navigate through rather than thinking about having to control. So the clip I'm going to play is from a live stream that I did last year with Interference Improvisation series in Flagstaff, Arizona, in collaboration with Arizona-based visual artist Kendra Solers. And hopefully my sound will work. Can I just come out of that? I'm going to put my sound. Is it HDMI? Yeah. Rolling video? Is that what I want? That's what I see. Let's try that. Okay, so why do I think about music in this way? How does it inform the instruments that I build, design, code, and the ways that I form collaborations? The video playing in this slide is from a long-term project I started with friends, colleagues in the UK, involving collaborations between musicians, and in this iteration in Arizona from a few years ago, also movement artists, dancers, people working with visuals, where we create performances that develop over several days based on somewhat non-hierarchical self-organization through what emerges as a group. So rather than getting together through a shared interest in a common instrument or piece of software, everyone brings their own unique individual approaches to the table, yet something wholly determined by the group's identity set up, but based on these individual approaches, starts to form and emerge. So in my case, I'm drawn to the ideas around embodiment specifically because I wasn't satisfied with what I perceived as a performer as a lack of sensuousness and physicality in live electronic music performance. So I looked to this notion of inactive music cognition, which emerged as a challenge or perhaps solution to approaches in musical research linked to traditional forms of cognitive science, which rely on the role of mental representations in musical experience. So these traditional cognitivist and computational theories of mind, the idea of the brain as a computer, require high-level information processing and internal representations for cognition. So this is a dualistic position where what happens in the brain is said to be separate from the body, where the body is said to not think. And this suggests a kind of two-stage process where information is picked up by the sensory system through physical encounters. This leads to a kind of excitation of nerves in the brain, and the second stage involves the stimulation of the nervous system, leading to a mental state or awareness of what's being gathered by the senses. So in the case of listening to music, of course, this would be sound picked up through the ears, but also the body, and perhaps through watching a musician perform. So it's multisensory in this model. The listener's brain would then process this information, or in the opposite way, the idea that music is conceived in the mind and then expressed through, for example, notation or composition, perhaps even algorithms or codes. But of course, we know that these distinctions are kind of unnecessary. Composers or improvisers' compositions are worked out through playing. The acts of notation, even coding itself, as we've seen today, are of course embodied. And live coder and researcher Joanne Armitage has spoken about this as well in her work. So, the inactive approach is based on the idea that cognition is formed in the process of living within social, cultural, and physical environments. The developmental process of identity and sense-making depends on the sensory, motor, and affective coupling between the individual and the world. So coming out of biology, psychology, and philosophy of mind, Varela, Thompson, and Roche first proposed inaction as a radical theoretical framework in cognitive science in the early 90s. More than 3 decades later, it's been developed as a rich theoretical and empirical platform for studies of consciousness. And in my own writing, I've argued that technologically mediated musical practices, particularly ones that involve improvisation, bespoke instrument design and making, are ideal sites to study this kind of skillful worldly engagement, or to explore musicking that isn't limited by background or ability or instrumental training, but in fact is specified by these things. So one of my favorite things is working with people who consider themselves to be non-musicians, who find out pretty quickly that that term is sort of meaningless when they often pretty rapidly create musically interesting or highly expressive or sophisticated ways of working with sounds. So I want to turn now to some of my own work in this area. So my entire approach to working with sound and technology involves encouraging whoever I'm performing with or teaching or collaborating with to explore their very specific individualized approach to creating new instruments and new music. So in a sense, to resist being limited by only what is, say, commercially available or dictated by genre, or uncritically building on, say, dominant lineages or practices of electronic music that are often problematic for a variety of reasons. So you might have seen in the first video that I'm using a PS2 controller to engage with all my hardware and software using Macs at the same time. I picked this up on the recommendation of somebody 15 years ago, and it's stuck, so I've been using it since. But it's not surprising, perhaps, that my background in classical piano from a very young age has led to this exploration of musical human-computer interaction that's largely focused around the expressive capacities of the hands and fingers. So I enacted my musical environment based around this very specific type of tactile engagement. And much of the work has been about exploring relationships between sound and touch for the performer through technology and improvisation. So on one hand, I think about using controllers, objects, materials for sculpting sound, and on the other, I work with vibration and haptics to allow me to feel the non-physicality of digital sound beyond what we can hear through loudspeakers. Also, I'll say though, through the inactive lens, I've been thinking a lot about how much of my sound world aesthetics and performance styles have also been influenced by my earlier years fronting punk bands and being deeply immersed in the Scottish drum and bass and techno scenes of the late 90s and early 2000s, so all very physical modes of musicking. And my interest in embodiment really stemmed from my first experiences performing with laptops and software, and missing not only the physicality and effort and struggle, but also the vibration, the resonance of instruments. So of course I can move a computer trackpad a few millimeters and hear massive rumbling bass sounds, but this left me feeling really disconnected from the ways I had learned over many years to engage with sound. So working with a gamepad as a controller that's actually so easy to move, so easy to change, there's no resistance in those joysticks really. So I found frictions within my system by having to hold these really still, so the smallest movements could make drastic changes in sound. So this was a way where I could find skillful engagement, the expressive boundaries within this setup. I also started developing haptic or touch-based technologies that would allow me to feel aspects of the digital music I was creating to offer a more embodied connection to my improvisations. So I found that even though I could hear the digital sound through monitors, through loudspeakers, I couldn't feel its resonance, its vibration. I felt really disconnected, having been used to, playing a piano, which is, of course, a huge physical resonating instrument. And aside from just working with electronics or digital systems, I also perform with a hybrid and digitally augmented piano. So in the piece I'll play in a moment, it was my first exploration of haptic feedback, so just using a simple Arduino microcontroller, vibration or pager motors, so simple technology worn as a glove. The system uses machine listening, so that all the musical material, acoustic or process, would be determined by what I was doing on the piano itself from the signals picked up through the microphones. I constructed algorithms to detect silence, phrasing, range on the keyboard. Of course, these things are all constructed. I'm deciding what silence means when I'm performing. And so thinking about these processes as algorithms, I'm not really interested in the accuracy or using them in ways that they were necessarily designed to be used for. So I don't care about getting correct pitch detection, but rather I'm seeing how that algorithm responds to this polyphonic, noisy, prepared piano in this case. So working with affordances of these computational processes combined with my messy instrument system. The piece uses lots of live sampling, slicing, chopping up, playing back, lots of attack and transient detection, all techniques that I use in most of my software. So again, this idea of evolution of one instrument's code informing the next. This piece didn't need any external controllers. Everything happened from this engagement. And I used an idea from the German composer Hans Tuchku to create sort of structured improvisation time windows, so it would allow me to kind of fluidly move through a somewhat predetermined kind of, score in a sense. The haptics would send both auditory information, so I start with a really simple mapping. The louder the sound, the more intense the vibrations. And also, it could send me symbolic information. So if I had to check for cues, or if I'd started a recording process, I wouldn't have to look at my screen. So I'm always trying to get away from the screens, particularly having spent the last 2 years on my screen in Zoom. And this work with haptics from my own experience as a musician has led to whole body compositions that can be heard and experienced through the whole body. Other people, of course, have worked in this area, like Half Matthews, for example. I've used haptic networks in ensemble improvisation with suggestive cueing systems, and more recent research collaborations with speech and hearing scientists looking at the role of haptics within music perception for cochlear implant wearers. So let me play a little clip of this video. Obviously, I can't convey the haptics, but maybe you can get an idea. Okay, the next example I'm going to show, I was interested in thinking about where the boundaries in electronic systems exist and how I can maybe put these together with physical boundaries of an already very physical instrument, acoustic piano. We know that the most interesting parts of working with sound are where things become unstable and fragile. So in the last talk, we were hearing about synchronous granulation, so these rhythms that emerge from the tiny grains. The delicacy of touch required to play harmonics on the guitar, for example, the tipping point of feedback, all these things are where we get like really interesting stuff to play with expressively. So in this piece, in this performance, I use a game track. It's very simple, cheap, computationally and cost-wise controller designed for playing PC golf. It's a really easy way to get XYZ data from two hands. And so it's measuring really crudely my hand position. I like cheap things that I can fix or replace if they break when I'm traveling and performing. So I looked at putting together boundaries of the physical instrument. How far can I reach inside the piano? Where do my hands most often come down on the keys? And matching these with interesting digital processes that might fit together. So as my hands start to play with a nuanced touch on the keyboard, perhaps I connect that to spectral freezing and phase vocoding, where I'm trying to capture a snapshot of the spectrum of the sound that's interesting to kind of meander around in. Or perhaps I can look at where my hands cross over on the keys, or which areas of the keyboard I tend to stay around, and similarly match these with digital processes that might make sense, perhaps cross-fading between two different samplers, for example. So rather than just machine listening to arrive at these flexible sort of timelines, I wanted to also couple the structure of the piece to my movement. So the way that I move around the instrument to sort of move through my software in a way that was completely tied to that. So the form of the improvisation emerges from my movement within it. I'll play a little excerpt. I'll show another couple of quick examples of other ways I've approached sound sculpting. So not just feeling the sound, but transforming it physically. So in the video, you can see little clips of this interface. Again, a repurposed games controller called the Novant Falcon. I think this is one of the last times I used notes on a page as a composer. Over 10 years ago. But this controller was something that Ed Bardal, a researcher, developed various models for within Max and Pure Data. Kyle Machulis, who works in the field of open source teledildonics, developed the firmware for it. So thanks to them, I was able to use it as a sound sculpting device. So there was various models like coiled spring that you could sort of really pull back and stretch, maybe couple that with stretching out sounds, or feel that you're moving through something really viscous like honey, or bouncing off different surfaces, or creating models that don't correspond to real world physics. So perhaps surfaces become smashed and they reconfigure themselves. Another really nice tangible interface was the AlphaSphere. I worked on creating a piece with one of their prototypes, again, back in 2010. So this had sort of haptic elastic pads. They were really stretchy, so you could sort of poke and push and press into them. So this seemed like something I wanted to put together with, just moving a low-pass filter around, and it's not by accident. If you look at some of the videos of this on YouTube, you'll see lots of examples using wobble bass as people are pushing into these pads. More recently, I was invited to be part of a research project at the University of Huddersfield called Fluid Corpus Manipulation. Some of you might be familiar with it, FluComa. It was developing new tools for sound decomposition and manipulation of large banks of sound files, and machine learning. So it was an opportunity for me to think about approaching some kind of machine learning through an already complex improvisation system that I have. So I worked on this idea of second-order improvisation, where I take a recording of my playing and re-perform with it, re-improvise with my system after it had been sort of analyzed and processed through some kind of first forays into machine learning for me using KNN algorithms, and then playing through those. So I'll play a short excerpt of how I use this in my latest release. So I'm curious about what we might learn by feeling through some of these algorithms, through embodied engagement with them, as opposed to just understanding how they work, perhaps. Okay, so most of what I talked about today is related to my own performance work. I wanted to finish by talking about one of the projects which speaks to how these ideas have led me to work with many different communities beyond just people who I might collaborate with or who might come to my shows, for example. So this was a project I started in Scotland in 2014 and later continued it in Arizona, where I live and work now, working with children, called Sound, Electronics and Music, which looked at how to use music technology, including Max, from an embodied perspective to create inclusive musicking for children through the idea of embodied learning. So when I say inclusion here, I'm simply talking about being able to make music without any prior experience necessarily, being aware of various barriers to access. So we explored using electronic music, working with sound in a material way, improvisation. I developed a 10-week course of primary school music education, which doesn't rely on having traditional musical literacy, nor being sort of tied to screen-dominated activities of musical technology. We explored low-cost DIY approaches and scaffolded it into wider learning through interdisciplinary applications related to other classes they were taking in science or electronics, and really explored how to give agency to the children by facilitating rapid prototyping using miniature synths, working with physical materials like junk objects, using codes in a way that would allow them to explore, but not just having them sort of sitting behind, having 28-year-olds sitting behind computer screens wouldn't have worked for a variety of reasons. So kind of coming in and being really open to letting them lead in a variety of ways. And this was really evident in additional support needs schools that we worked in, where we had to be really flexible and not just coming in and saying, here's my thing that I've built, now you're going to use this. So yeah, in conclusion, I want to be clear that I don't believe everyone should be working with haptic technologies or creating gestural musical systems. People who didn't move from, say, acoustic instruments to electronic ones may not experience this loss of physicality in the way that I did. We just saw an example of working with iPads in a way that is trying to be more physical, and that might appeal to you. I worked with people who have deep embodied relationships with, for example, the layout of buttons on a mobile phone for, say, text-to-speech algorithms, and who want to explore music creation in this way. So embodiment is not just about physicality, but rather thinking about how to incorporate the richness of ways of living musical lives that might be possible through our own unique embodied and cultured musical histories. Perhaps technologies, algorithms, humanly explored, felt, and critiqued can help us to do this. Thank you.